So, quick reminder as we begin. First of all, there are tutorial videos from the old Math 12, well, the old Principles of Math 12 course on my website. Go to www.pitmath.com. If you do that, click on Principles of Math 12 links. Click here. And if you scroll down, there's 2 review tutorials on this side. If you want extra combinatorics practice, there is more here. I'm not as fond of these ones as the one that I gave you. The one that I gave you has lots of practice and there's plenty of stuff. I don't think you guys need extra practice. Most of you haven't done the one that I gave you. How's the test going to look? We're going to start with the fundamental counting principle. What are some questions similar to the fundamental or that use the fundamental counting principle? Give me a second and I'll find some. Combinatorics review number 2. This will work. Something like this. Tim and Rebecca are the first and second students in a line of 7 students waiting to buy tickets for a concert. The number of different ways that the remaining students can line up behind them is, okay. This is the fundamental counting principle. This is also probably going to be a permutation because I'm seeing the number of different ways something can line up. But I would handle this by going, okay, we have the first and second students. So I guess if I look at this here, I have 7 students grand total. The fundamental counting principle, our strategy was draw blank. Draw blank. There may be better ways to do it, but I start out there. Oh, that's a little big, Mr. Dueck. I start out there, and then sometimes I can use an NPR or a factorial shortcut afterwards, but I spot the pattern like this. I think it says that Tim is first and that Rebecca is second. How many ways do I have to pick Tim? 1. How many ways do I have to pick Rebecca? 1. Right? How many kids are left? Then? So as a shortcut, as I look at this, I guess I could have gone 5 factorial, because I do see 5 times 4 times 3 times 2 times 1, and 1 times 1. So the answer here, I guess they wanted in simplified form, is A. Again, what's the fundamental counting principle? It says if you're making choices and you can represent each choice with a blank, you multiply the number of steps together. You multiply. Fundamental counting principle says you multiply choices. Or as I've told you, and means multiply. Because what you're saying is there's Tim and Rebecca and the 5th guy and the 4th guy and the 3rd person and means multiply. Another example of a fundamental counting principle kind of a question, license plate questions. Oh, here we go. That's a little bit yucky. Order does not matter. That's not a fundamental counting principle. This is why I didn't give out this review. I'm just looking for some nice typewritten questions. Well, something like this. Example. A license plate has 4 letters followed by 4 numbers. How many different license plates, spell it with an S, Mr. Dueck, can be created if we, and I'll just make this up because it's kind of dumb, if we are not allowed to repeat letters and numbers. That's dumb because in real life you can repeat letters and numbers, but I'm just making up a dumb math question. So how would I handle this? I would draw 8 blanks. 1, 2, 3, 4. 1, 2, 3, 4. How many choices? Can I help you, Peter? Yeah. How many different license plates can be created if we're not, oh, how many choices do I have for the first letter? There's 4 letters. How many choices do I have for the first letter? 26. Then 25, because it says not repeating. Then. Now this also happens to be 26P4, but you know what? It's not that much longer just to write out the blanks and write out all, because that's from 26 letters, permutate 4 at a time. And then it says 4 numbers. How many choices do I have for the first number? How many choices do I have for the first number, folks? 10. Then. And this happens to be what? 10P4. Remember, 26P4 is actually 26 factorial over 22 factorial. I could actually give you the question looking like that as an answer to pick from instead of the actual value. And 10P4 is actually 10 factorial over 6 factorial. Right? The factorial, the number didn't, this number, come on. This number didn't appear down there. What appeared down here was this minus this number, right? The difference. We talked about why that worked. So there's going to be some kind of a fundamental counting principle or 2 question. You're looking very confused and you muttered a bad word without actually saying it out loud, but I read your lips. Rosanna, what's your question?
How did you get 26 4 to 26 over?
Could you shut the door behind you, please? Give your yellow formula sheet out, please.
Yeah.
Get it out. Read me the NPR formula, please. It says this. NPR is defined as what?
N
Factorial over
minus r bracket.
Can you see where the 22 came from now? What is the bottom? N minus r, the first number minus the second one. That's how we, because why? Let me do it with this one here because it's shorter. What we're really saying is this. The top is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What's 6 factorial? Okay. Can you see, Rosanna? Those would cancel, 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 and I'm left with what I wanted there. The only way that works is if in the bottom I don't put 4 factorial, I put 10 minus 4 factorial. That's what goes on the bottom. N minus r factorial is what has to go on the bottom so I can get all these to cancel and be left with the 4 digits that I want to multiply together. Is that okay? Okay. Christina, you can watch or you can write, but I'll print this up for you after. So there's going to be a few questions on fundamental counting principle. Then we moved into permutations. What's an example of a permutation? How many ways can, I don't know, 8 books be arranged on a desk? How do I know that's a permutation? Okay. Other words? Shuffled, ordered. What are some other words that? Oh, mixed up. Can you think of some other synonyms? I think I almost always used arranged, but I can't guarantee that. It's going to be fairly clear, and you'll also know because it's going to be question 2 or question 3 or question 4. The first question, or maybe the first 2 questions, are going to be fundamental counting principle. The next couple of questions are going to be permutations. What's the answer here, by the way? How many ways? How can I calculate how many ways can 7 books be arranged on a desk? Some of you are in trouble. If you don't know this, you're in trouble. Okay, the long way would be to draw 8 blanks and then say, well, I got 8 books to pick from. Then how many? Then, hey, what's the short way to do that? Okay. I could either have, if this was multiple choice, and the first half of your test is multiple choice, it's going to be fairly similar to the big review package I gave you. I could either have that as an answer, or the actual evaluate. What is 8 factorial? Is that 7? No. 6 factorial is 720. 7 factorial is 2,000. I don't know what 8 factorial is. Big. 40,320. Okay.
I thought a permutation was one that has to be in order.
Yeah, and
But it doesn't matter which order.
And another word for order is that one there. That's a trigger word that you know it's a permutation and not a combination. Other words, I could say, how many ways can 8 books be shuffled? In fact, we did a question on your quiz where it was shuffling music, right? Rosanna was the DJ. Okay, shuffled, that's a permutation. Or ordered, that's an obvious one. Mixed up, those will be the main ones, I think. Okay, I could give you the same question if we take them 3 at a time. So suppose I have 8 books, but my desk only has room for 3 of them. How many different ways can I rearrange them? Okay, so how can I write this? There's 3 different ways I can write this. The shortest way, which is what? Please, get your calculator. Which is what?
Oh, 336.
Sorry?
330.
336? Okay, so that's one way. I could have that to pick from. Other answers to pick from would be like 8C3, 8P4, 8P5, 8C5, whatever. I could write it like this. Because that's what the definition of 8P3 is. And again, Rosanna, the common mistake, kids want to think that 8P3 is 8 factorial over 3 factorial. It's not. It's 8 factorial over n minus r factorial. It's 8 factorial over 5 factorial. That's what your calculator is doing. I could have that to pick from if this was multiple choice. Or I could actually have 8 times 7 times 6 and just leave it like that. Because that's what you would do if you drew blanks. We started here, this was the fundamental counting principle, and we eventually got to the permutation. Okay?
You can't do the 8 choose 3 though. You
I didn't say choose.
said 8. You said that's an option.
No. If I was making up a multiple choice question, I would go something like this. A, 8P3, B, 8C3, C, 8P5, D, 8C5. I would do something. I have to come up with good wrong answers for a multiple choice question. Okay? Is that all right? So yeah, and some kids would choose for what it's worth. Okay? Then we did permutations with repetitions. As an example, how many ways can you rearrange the letters of Rosanna? Okay? What was different about this one from the 8 books or from the word? Okay, letters repeat. You know what? Let's compare that with the letters of the word Kelvin, my name. So in my name, do any letters repeat?
No.
So this would be just plain old 6 factorial, or it's from 6P6. In Rosanna's name, we would go 1, 2, 3, 4, 5, 6, 7 factorial over how many R's? 1, yeah. How many O's? 1. Oh, you know what? 2 A's, 2 N's. Whatever the heck that is. Whatever the heck this is. We did a lot of word questions because we said with a bit of cleverness, it was fairly easy to change almost any question into a word. We changed pathway questions, for example, into words with repetitive letters. We changed true-false tests into words with T's and F's everywhere, right? By the way, 6 factorial, this I know is 720. How many ways can we rearrange the letters of the word Rosanna? Oh, I got 2 different answers. 1,260 is right. Did you put brackets around the bottom, Rosanna? Because if you didn't, then you went 7 factorial divided by 2 factorial times 2 because your calculator wouldn't know it's on the bottom. Yep.
Can you print me an extra copy and pick it up tomorrow?
I'll email it to you, or it'll be online.
Okay.
You can print it up at home.
Email it to me then?
I'll put it on the website. So
Okay.
what's my website? Pitmath. Click on today's notes. It'll be there.
Okay, thank you.
I'm making you responsible, Connor. Yes, you. Okay. So it's going to be some kind of letters. It'll probably be a little tougher than Rosanna, Mississippi, or something with a bit of oomph to it. Okay. Here is my test. Let me see. Words. Okay, then there's going to be some type of question with a condition. Let me see if I can find you a good example here. Here's a good fundamental counting principle question, by the way, so look up. It says 5 different outfits are to be displayed in a store window. From the 5 different winter outfits, choose 3. From 4 different fall outfits, choose 2. Permutate, arrange 2, because it does say arranged right there. So let's try this one here. Here's a nice combination question. Yoink. By the way, if you're wondering where these are from the old Alberta provincial exam, which did a similar curriculum to us. So I managed to find some copies of those. Okay? Now, you might say, is this a choose or is this a permutation? See that? Oh, that didn't show up. See that word right there? I think, and it says it again there, I think this is a permutation. So I think we're going from 5 different winter outfits. What? Permutate 3. And from 4 different fall outfits. Permutate 2. See, you could also have done it like this. You could have said, I'm choosing 5 outfits, and it's winter, 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 fall, fall. How many ways do I have to pick a winter outfit? 5, then 4, then 3. How many ways do I have to pick a fall outfit? 4, then 3. These will both give you the same answer. My fallback is drawing a blank. I'm good at that. But this one here, I felt comfortable enough to use the permutation shortcuts. I think the next one had some nice conditions on it, though. Sure. Here's what I mean by permutations with a condition, like number 18 here. Read along with me. It says this. A set of 3 different math books, 4 different physics books. Oh, I like this library. Okay, 2 different English. My English is more gooder, sure. Are arranged on a shelf. Probably a permutation. If the books on each subject are to be kept together, then the number of different arrangements possible for the books is... Oh, you know what, Mr. Dueck? I think I need to take this answer and multiply by 2, because it didn't say that the winter had to come before the fall, did it? I could go falls first, then winters, or winters first, then falls. I wouldn't give you one quite this wonky, but I just thinking about it as my brain moved on. I think this level of complexity, totally fair game. I don't know if I'd throw... You know what? Maybe as one multiple choice, I'd feel comfy throwing a curveball like that, but the written's going to be fairly straightforward, except for one question. let's look at this. It looks like here, initially I was going to say, oh, just mix up all the books. But then it says if, here's my condition, if what? The books on each subject are. So now what I'm going to imagine, I think, is my Scrabble bag analogy. And here's what I mean. There's going to be this weird Scrabble bag with letters in it, because I said I can turn almost anything into a word, except what's the condition if what? Okay, so I'm going to imagine a weird Scrabble tile with 3 math books. I'll call them M1, M2, and M3. 4 physics books. And 2 English books. You okay with that? How many letters are there in the Scrabble bag? How many tiles are there in the Scrabble bag?
3.
So I'm going to say, first of all, I can mix them up that way. But now it also says I can mix up each one of these. Right? It says, how many ways can I arrange them? I got to keep the books together by subject, but I can mix the subject, I can mix them up themselves. How many ways can I mix up the math books? And how many ways can I mix up the English books? And how many ways can I mix up the physics books? So it's how many ways to mix up math? How many ways to mix up English? How many ways to mix up physics? How many ways to mix up the 3 subjects? That's what I mean by something with some kind of a condition. There's going to be one like that on your multiple choice, and I think there's going to be one like that on your written. I'm going to give you one to make you think. And I'll tell you, it's going to be the last question on the written. I will drop a hint about it sometime today for those of you that are here. If you're paying attention, I may say I like this question for a very, very similar one. But certainly for this here, I'm going to say, yeah, I like this question, I like this question, I like this question. And what I mean by that is tiles with more than one letter in my Scrabble bag. Absolutely, you're going to have one like that on your test. Okay? And we did do some in our homework. If you look at the lesson 1 homework, some of the nasties that I attached, where we had words with conditions. Okay? Another way to give you some kind of a condition would be something like this. Let me see. No, that's good. That's good. You know what? I think I've given you a good hint. So we did we started out fundamental counting principle. We did permutations with repetitions. We did stuff with weird conditions. We said always do the condition first. If it's a word, and even if it's talking about the last letter, do it first. And then go back to the other ones. Read carefully. Then we got into combinations. Order didn't matter. How could you tell that order didn't matter? As examples, you know what? Let's make it emphasis. Committees and cards are combinations. Oh, I didn't want to do that, Mr. Dueck. Control B. Committees and cards, are you spotting a trend here? Are combinations. I got to be a little bit careful unless the committee, for example, started talking about positions. Or unless the card clearly says something like, first you pick an ace, then you pick a king. Unless it very clearly mentions an order, but it'll be obvious for cards. Most of the time in most card games, you don't care when you picked it, you just care if you picked it. Okay? So what will you see? Something like this. Committee is being formed with from 9 females and 10 males. How many ways can the committee be formed if it must consist of A, 7 people? Can you read A to me, please, Christina? 7 people. Did they distinguish between genders in this condition here?
No.
Okay, so no subgroups. I would just say, you know what? From 19, choose 7. Whatever the heck that is, I don't know, but I'm going to assume you can type that. Okay? Again, though, be aware that this is also 19 factorial over 7 factorial, 12 factorial. If this was multiple choice, I could give you that to pick from, the factorial form. That's what the formula is on your yellow formula sheet. What if it must consist of 4 females and 3 males? What was our strategy when they gave us subgroups? One word, bucket. So I would go over here, and I would say, okay, I got females, males, 9, then 10. You got to go? Okay. 4, 3, what's the equation?
Wait, how did you get 9 males and
9 females.
females and 10 males?
I don't know, how did I get that?
It's said in the question, formed from 9 males and 10
And it
females.
says 4 females and 3 males.
Yeah, that's it,
Got the
right?
original.
That's the total in the bucket. That's the total in the bucket. There's like cards. That's how many I'm choosing. That's how many I'm choosing. So what choose what? What choose what?
9 choose 4.
And I remember, really what we're saying is this. 9 choose 4 and means multiply. 10 choose 3. I could leave that as an answer to pick from. I could evaluate it as an answer to pick from. Or I could say, hey, this is actually, need more room, Mr. Dueck? 9 factorial over 5, 4, and 10 factorial over 3. I could have that to pick from as well. Probably not, because this is a lot of typing. I'd probably here want you to evaluate. I guarantee on the written section, you're going to see a committee question where I start out like this, and then I'm going to do an at least or an at most question. So, the committee consists of 7 people. I said, okay, 4 females and 3 males. What if I said at most 2 males? So it's still got to have 7 people. At most 2 males. As soon as I use at most or at least, please list all of the cases. That's the best thing you can do to avoid making a mistake. So what does at most 2 males mean? I'll give you a hint. 2 males or don't forget the 0. That's the common one as well, which is kind of why I like this one in some ways, because kids always forget the 0. It's a good way to reinforce. Remember we said with our whole binomial expansion theorem, we were counting starting with 0, right? So I would write this out. 2 or 1 or 0. I usually underline them as kind of, that's what I'm going to do. I would draw my bucket. So we had females, males, I think it was 9 and 10. Now, if we have 2 males, how many females? If we're putting 7, okay. So the first one is going to be 9 choose 5 and 10 choose 2, or means add. 1 male, 6 females. 9 choose 6 and 10 choose 1. If you're really lazy, you may have already noticed 10 choose 1 is 10. Anything choose 1 is itself. So you could save time just typing a 10. It's up to you. Or no males, 7 females. 9 choose 7 and 10 choose 0. And you may have noticed, what's anything choose 0? 1, you could save yourself the typing, but I would certainly still write it out because there's some nice symmetry. You'll notice there's patterns, right? You'll notice, girls is going up by 1, guys is going down by 1. Okay. So there's going to be some kind of a committee question. There's going to be a pathway question. In fact, there's going to be two. It's going to be one pathway question on your multiple choice. It's going to be a regular pathway. You can use Pascal's if you want, but you can turn that one into a word as a shortcut. Okay? And by a pathway question that's regular, you guys are looking out in the hallway. You guys back here? Rosanna, I am talking to you. You're back here? Okay. Here's a great example of a pathway regular question. Let me copy it into here. Clip. Most common mistake that I see is this one. So kids spot it's regular because there's no weird missing lines and no overlap. And they go like this. Right. Oh, turn your pen on, Mr. Dueck. Right, 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 down, down, right, down. And they go, oh, Mr. Dueck, this is 1, 2, 3, 4, 5, 6, 7 factorial. This is wrong. Don't write this down. They go, it's 7 factorial over 4r's 3D. No. Those are two separate rectangles. There's the bigger rectangle and the smaller rectangle. Listen closely, listen closely, listen closely. Here's how you solve this. You need to realize that you have to go, listen close, through this rectangle and this rectangle. What does and mean? There's going to be timesing. The first rectangle is 5 letters, 3 R's, 2 D's. The second rectangle is 2 letters, 1 and 1. And you have to be able to evaluate that. Now, something I did not show you guys in class, but if you're looking for a shortcut. You looking for me, sir?
No.
Okay. Those of you that are particularly, is that okay, Justin?
Yeah.
You look stunned.
I get it.
You good?
Yeah.
Okay. There is a shortcut. If you're particularly astute, you may notice that this is actually 5 choose 2. Because 5 choose 2 was 5 factorial over 2 factorial, 3 factorial. Or it's also 5 choose 3. You may notice that this is actually 2 choose 1. It is. That's just a wonderful coincidence in regular pathway problems. If you want, as it turns out, each rectangle ends up being a choose. I'm not saying it's a choose because order doesn't matter. I'm just saying the mathematics of it happens to exactly match the choose formula. And if you want to, you can use it as a shortcut. You can survive just fine without that by using the factorials like the top line. Okay?
You can just use the lines, right? One line.
The lines. The lines.
Like one.
Pascal's? Absolutely. Pascal's will work as well. And in fact, on the written, I'm going to give you an irregular pathway problem where you have to use Pascal's. Let me see if I can find one here. Sure, right here. Do you know how I can tell it's irregular? That guy. We're missing a square. So the only way to solve this one is going to be with Pascal's. All I would say, Rosanna, with Pascal's, it's so wonderfully easy. Be really careful and paranoid. Because what I see all the time is they start out very careful. In the middle, they get into kind of a rhythm. They get relaxed and they make a dumb mistake. Or often, the number of times I'll see a mistake on the last line or second last line because they've started to relax drives me crazy. So don't do that. Let's go. What do you want to go from house A to house B? Let's go from the top to the bottom. Ready? So I'm going to hover over each corner. You tell me what to write, starting here. 1. Hang on, I want it to go red, Mr. Dueck, so it stands out more. 1. What am I writing here?
1.
Call it out.
1. 2.
Why 2? Because you think about what's flowing into it. A 1 and a 1. 2. Is that okay, Brooke? Yeah? What's going to go right here?
2.
Because it's 2 plus 0. What's going to go right here?
2.
What's going to go right here?
2.
2. How about here?
4.
4, because it's 2 and 2 flowing in. 6. How about here?
4.
Because it's 4 plus nothing.
Smart. I can't solve it.
Okay? What's going right here?
10.
By the way, you'll notice what I'm not doing, and this is, I think it was Christina or it was Brooke, someone I was yelling at, kept moving down. Do not move down. You move across, do the whole row. Okay? Here is a 10 as well, you said? How about on the top left corner right here? 10, 20, 10, 30, 30. Okay? You cannot, sorry. There is no easy, I was going to say you cannot. There's no easy way to get there using chooses and permutations and factorials. It can be done, by the way. The way you could do it is you could actually figure out how many ways you lose with this cutout and subtract. Yeah, it's faster to just Pascal. Okay? What do you need to be? A little paranoid when you're doing the math. What else will you see? So now we're into everything. On the written section, everything is fair. Oh, the binomial expansion theorem. Oh, you know what? Before I do that, on the multiple choice, I think it's on the multiple choice, or is it on the written, Mr. Dueck? Multiple choice. What is the fourth term of the 32nd row of Pascal's triangle? Now, before you call this out, I think if this is multiple choice, here's what I'll have for you to pick from. A, 32, choose 4. B, 31, choose 4. C, 32, choose 3. D, 31, choose 3. That's what I'll give you. I won't actually give you the numbers. What is the fourth term of the 32nd row of Pascal's triangle? 31, choose 3. Yep, minus 1, minus 1. Okay. If you blank out, write out the first couple of terms of Pascal's triangle. Remember that the top one, that little 1 by itself, is not 1, choose 1. It's 0, choose 0, because we start out counting with 0. Then the next row of 1, 1, that's 1, choose 0, 1, choose 1. Okay? So, let's say this, Mr. Dueck. Written section. It's a little small, but that's okay. Oh, I did that wrong again. There. So what do you see on the written section? There's going to be an irregular pathway. That's actually the second question. I'm going to take Pascal's triangle, and I'm actually going to go like this. Cut. And I'm going to paste it. Nope. Didn't want to do that after all. I want to go click right here, insert, space. Aha. Paste. Okay, on the written, there's going to be a pathway question. This is the second written question for those of you who are following. What's the, pathway question is going to be the second written question, but it's going to be an irregular pathway problem like this. Let's put that, Mr. Dueck. Come on, let me click. Well, whatever. Binomial expansion theorem. First written question. Write out the first 4 terms of, let me make sure I don't accidentally make up the same question because that would be a little silly. 3x minus 2y squared to the 11th. And let me just fix this and get the exponents in there. Here, exponent. Here, exponent. Okay. I'm going to ask you to write out the first 4 terms. How do I write out the first 4 terms? This is the binomial expansion theorem. Talk me through this. What would you do?
You would do the formula, wouldn't
No, isn't this like the 4?
That's for one term, but if you want to write 4, there's a pattern.
Isn't it like 4 choose 0, 4 choose 1, 4 choose...
I agree with the choose 0, choose 1, choose 2.
11 choose.
Why 11? What's the key to doing this question? Not how many, not that 4 has nothing to do with it. I'm just saying do the first 4 and quit, but that doesn't tell you the actual equation. What's n?
Oh,
What's n? Foster.
11.
11. I would start out going like this, boys and girls. I would say to myself, it's going to be 11 choose 0, 11. Come on, Dueck, write bigger. Oh, come on, pen. Sorry, guys, my pen has been acting up all day. 11 choose 2, 11 choose 3. Now what?
and now,
Now what, Rob?
You put
A choose,
A
or A1.
to the 11th. Okay, but folks, you need to know this. We spent 2 days on this.
A10?
A to the 10th, A10 is battleship. A to the 10th is math. A10, B5, that's battleship. A to the 9th. By the way, I do that as a joke, but what I'm really trying to do is need to reinforce it's an exponent, and that number is going to follow the exponent laws, not the regular laws. So don't start calling it a non-exponent. Let's even subconsciously reinforce that. A to the what? A to the 8th. B to the what? Okay, you start out with your template. Okay, by the way, what's my great big exponent? What's n? 11. How many terms are there?
4.
No, not what I'm asking. How many terms are there, grand total? 12. That's why I'm not going to ask you to FOIL this whole thing out, because that would be 12 terms. That's ridiculous. I'll ask you for the first 3 or 4. Okay, that's where the 4 comes in. Nothing to do with the actual math. It's just write out the first 4 and quit. You with me, okay, Brooke? Now we carefully. Oh, by the way, I would also probably say this. In this question, what's A and what's B?
3x.
Negative 2y.
2y squared.
Okay. This is, if you do this carefully, plug and chug easy marks. This is going to be worth either 2 marks, half mark for each term, or 4 marks, 1 mark for each. Well, why don't you look, Mr. Dueck? Good point. Can't remember what I made this one worth. I made it worth 4 marks, 1 mark for each term, which I hope means easy marks as long as you're careful. Now, you have to be able to reproduce this pattern, and the fact that many of you were going, means some of you need to practice. You know what? On the big review, on the written section, you're going to find 5 or 6 of these if you haven't got that far yet. Okay? What is 11 choose 0? So that's a 1, and then it's going to be a 3x all to the 11th, because A to the 11th, plus. What's 11 choose 1? I think that's 11. And then it's going to be a 3x to the 10th, negative 2y to the 1. And you'll notice I'm being really, y squared, thank you. You'll notice I'm being really careful. I'm even putting 1s where normally I don't, because I'm normally lazy, not here. Plus, what's 11 choose 2? 55. And there's going to be a 3x to the 9th. And a negative 2y squared plus, what's 11 choose? Sorry? 3x to the 8th, negative 2y squared cubed. Now, this is something that I should have done when I taught you this next step, and I did it all in one step. I skipped this next step, and I think I lost a few of you, and I'm kicking myself. Now what I would do is I would drop the 1 down. I know it's going to vanish later, but that's okay. I would say, you know what? This is 3 to the 11th, x to the 11th. I skipped that step. I just distributed the exponent all in one fell swoop, and I think I lost a few of you. Some of you didn't realize the exponent goes on to everything in the brackets. Plus, the 11 drops down. It's a 3 to the 10th, an x to the 10th, a negative 2 to the 1, and a y squared to the 1. Do you see how the 1 went on everything in the brackets and the 10 went on everything in the brackets? Follow it? Plus a 55 3 to the what? 9th. X to the what? Negative 2 to the what? Squared. Y squared to the what? Squared. Plus 165. 3 to the what? Y to the, sorry, Y, Mr. Dueck. X to the negative 2 to the third. Running out of room, Mr. D. Y squared to the, all right. Well, I got this all fitting on the screen still. So now this first term, I can tell you the variables already. I can tell you in the first term, I'm going to end up with x to the 11th. See it? And you know what? I can tell you in the second term, I'm going to end up with x to the 10th y squared. See it? What am I going to end up with in the third term? X to the 9th, y to the, careful. Yeah, there's going to be an, and in the last term, there's going to be an x to the 8th, y to the, careful, 6. It's the coefficients that are the tricky part. The coefficients are going to come from, in the first term, just 3 to the 11th, which is going to be pretty huge, 17747. No, I missed that. 177147. It's going, I saw 6 digits and I only remember 5. 177,147. It could be a plus or a minus here. I'm not sure. It depends on whether this term ends up being negative or positive. If it's positive, I'll put a plus. If it's negative, I'll put a minus. How will I figure that out? Look at all the coefficients. Look at all the numbers. It's going to be 11 times, there's a 3 to the 10th times, there's a negative 2 to the 1. Probably didn't need to type the 1, but I'm going to be a little paranoid and do it anyways. Do you see where all those came from, Rosanna? Yeah? See where all they came from? All those came from? You'll notice I put the numbers in brackets and the exponents outside the brackets just to be extra super special careful. Negative, so it's going to be minus 1299078. Minus 1299078 x to the 10th y squared. That's the second term. The third term is going to have, come on, a 55 times a 3 to the 9th times a negative 2 squared as its coefficient, and then x to the 9th, y to the 4th. The third term is going to have a 4330260 positive. 4330260 x to the 9th, y to the 4th. The fourth term, by the way, can you see ahead of time the fourth term is going to be negative? Because here's my negative, and this exponent out here, is it odd or even? It's odd. When you go negative times negative times negative, you get one negative left behind. I figured it's going to be positive, negative, positive, negative. It's going to be 165 times bracket 3 to the 8th times bracket negative 2 to the 3rd. And I get negative 8660520. Negative 8660520. And then don't forget the x to the 8th, y to the 6th. Okay? That's probably slightly tougher than I'll give you on your test. On your test, there's 3 things I did here. I put coefficients in front of both letters. I made one term negative, and I put an exponent inside the brackets. I'm going to do 2 of those 3. I won't do all 3. You'll either have coefficients, or you'll have a negative, or you'll have an exponent. 2 of those, but not all 3 of those. Just, this is a little overkill in my mind. Is that all right? Now, Rosanna, on your multiple choice, I'm going to ask you to find one term. So, from this same binomial, How many terms did we say there were here? 12. Find the 7th term. This will probably be a multiple choice question. Might be a written. To find a single term, here's where I use that formula, which you're just dying to spit out to me. So can you read me that there formula, Rosanna, the one that you showed me in the cafeteria so eloquently? T sub k plus 1 equals?
N to K, and then A in bracket,
Yep.
and N minus K in exponent.
Thank you. How about to the and minus k? B to the, okay? And over here, I write term 7 equals, because what I want you to recognize, that's term 7 written out. This is term 7 as I want it to fill in. How do I get that to become a 7? What does k need to be? So you need to memorize that we adjust k, but you also need to know from the original binomial what's n, what's a, and what's b. From the original binomial, what's n? 11. What's a? 3x. What's b? Negative 2y squared. Once you have that, this is plug and chug. Ugly plug and chug? Yes. But it is plug and chug. It's going to be what choose what? 11 choose 6. That's what it says right here. N choose k. N choose k. Yes? Times a, 3x to the third? To the third? Can you read to me what it says here? Read n minus k. 11 take away 6. 5. Negative 2y squared to the what? To the k. K is 6. Now it's exactly like this line here in red, because now I have some choose notation, some exponents, and some variables. Now it's going to be, okay, term 7. What is 11 choose 6? 462. That's that. There's going to be a 3 to the 5th, an x to the 5th, a negative 2 to the 6th, and a y squared to the 6th. Yes? By the way, can you tell me what the variables are going to be? X to the what? Y to the? I've seen, not term 8, Mr. Dueck, term 7. I've seen on some provincials that all you needed to do was get that, and you could cross out all of the wrong answers already, because none of them had an x to the 5th, y to the 12th. In fact, I think the one we were doing in the cafeteria, we didn't actually have to finish. We figured out it was positive, so we crossed out the negatives, and then we just got the exponents in place and said, oh, we're done, although we did finish it. And let's finish this. And I'm going to need more room, Mr. Dueck. Oh, no, I'm not. It's going to be in front, the coefficient. Oh, by the way, another way for me to ask this same question is instead of saying find the term, I could just say find the coefficient. And a lot of students will say, oh, the coefficient is just 11, choose 6, forgetting that actually that 3 to the 5th also gets swallowed up by the coefficient, and that negative 2 to the 6th also gets swallowed up by the coefficient, yes? So it's going to be 462 times, 406, come on, Mr. Duke, 462 times, bracket, 3 to the 5th times, bracket, negative 2 to the 6th. What's the coefficient actually going to be? 7185024. 7185024, x to the 5th, y to the 12th.
You don't put the brackets around the 3, does that mean the answer?
No, but if you don't put the brackets around the negative 2, it will. I'll show you what I mean. So I get in the habit of doing it around both anyhow. If you go like this, and if you go like this, what's the difference? So that top one, my calculator didn't know that I wanted the exponent to also go on the negative. So if I want the exponent to be on the negative, I put the whole thing in brackets with the exponent outside the brackets. Otherwise, my calculator, because it's a computer, it's not smart, it won't know. Okay? 2 more questions I want to talk about. 3 more questions. Are you guys okay for another 20 minutes or so?
Yeah. I just have to go. I have no service. I'm supposed to go at 4.
Okay. Then I'll do one that I think you're okay on, and when you come back, I'll do the nasty. Card question. Card questions. Chooses or not? Okay. Choose. And it'll be an at least or at most question. On the written, I'm going to give you some kind of a card question. Pick 5 cards, let's say, because that's a nice 5-card poker hand. And I'll say, how many ways are there, as an example? Make sure I don't make up the same question, Mr. Dueck. That's always a problem. How many ways are there to get a hand with, I don't know, to get a 5-card hand with at least 3 black cards? What would at least 3 black cards include? I want the cases. I know it's 3 or more. Or 4 or 5. So is there subgroups here? Hey, what are the groups for cards? If I'm talking about black cards, what's the other group that I have to clue in on that they didn't mention? Red cards, so you get bucket. Okay? There will be a factorial algebra equation to solve. Example. Solve algebraically. And I can't make these up, but give me a second. Better make sure I don't make up the same one that's on the test, Mr. Dueck. Where is it on this calculator? Sure. N choose 2 equals 10. Okay. By the way, again, you can always guess in your answer. You could try really quickly. 1 choose. I guess 1 choose 2 wouldn't make sense because you can't pick 2 objects from one thing. So I wouldn't try 1, but you could try choose 2, 2 choose 2, 2 choose 3 choose 2, 4 choose 2, 5 choose 2, 6. You can find the answer. But I said solve how? Solve how? Algebraically. What I'm really saying is you better show me some work. This is where we get the rejection. This is where Roy can't get a date. Okay? How do we do this? You got your yellow formula sheet out? Can you tell me the formula for n choose r? Except, look up. Instead of an r, what's sitting where the r is? The number?
2.
So read me that formula, but don't say any r's, say twoses instead. N, yeah, I got that. I want the other side. The stuff with factorials in it. Yep. Yep. Yes. Okay. This question is going to be worth 2 marks. It should be worth more because it's a lot of work, but I don't want to make it worth more because it's tough. That'll get you a half mark. If you clue in, I know how to translate algebraically into the choose formula on my formula sheet. Oh, and by the way, what is 2 factorial on the bottom there work out to? So on my next line, it's going to become a 2, and I would want to move it to the other side. Right now, on the left-hand side, I'm dividing by 2, So how will I move it over to the other side? What's the opposite of dividing by 2? So on the next line, I would say this. Times by 2. And I'll have n factorial all over n minus 2 factorial. You okay with that? Now what? Well, the right-hand side, what is 10 times 2? So on my next line, it's going to become a 20. On the left-hand side, question? Okay. We're gonna simplify we need to. There is no way to do math with factorials. What we have to do is find some way to get the factorials to cancel. And to do that, we expand one of them. Which one? Whichever one is bigger. Which one's bigger? In this case, the top. So I'm going to expand it into n times n minus 1 times n minus 2. Stop there, stop there, stop there, because that's what you wanted to cancel out on the bottom. Ha-ha! That gives me n times n minus 1 equals 20. Now what? Distribute, front door bomber, get rid of brackets, expand, whatever your teacher called it, do it. It's going to be n squared minus n equals 20. What kind of an equation is this? It's a quadratic. How do I know? It's got a squared. How did you learn last year to solve a quadratic before you did anything else? What's the first thing you did? You have to make it equal to 0. So I'm going to minus 20 from both sides. I'll get n squared minus n minus 20 equals 0. And you guys did, like, I think a whole unit on this last year in Foundations 11. You did the quadratic formula, which you can use, although I haven't given it to you. Or these ones will always factor. Why? Because when I make them up, I have to start with whole numbers because I'm starting with groups of people. And I don't want to be picking 3.3 people because 0.3 of a person means something's gone horribly wrong, right? So you're looking for two numbers that multiply to negative 20 and add to negative 1. Don't all call them out at once. What are two numbers that multiply to negative 20 and add to negative 1?
Negative 5.
5 and 4 are 1 apart, and I want to get a negative 1. I think I can make it work with 5 and 4. Yes? So it's going to be like this. And by the way, if you can't get this, you need to work on your times tables. Sorry. And positive 5 or positive 4? Which one's positive, which one's negative? I want the 4 positive and the 5 negative in the factors, because that gives me the negative 1 right there. But when I take the roots, what are the roots? 5, negative 4, and then poor Roy. Okay? So it's going to be one of those. Last one. And we're done. I think. Let me just double check to make sure I've covered everything. Brooke, while you were out, I said there's going to be some kind of a card question on the written section with at least or at most. So as an example, how many ways are there to get a 5-card hand with at least 3 black cards? That would mean 3 or 4 or 5, and use a bucket because it's cards. Is that okay? If not, I'll go over that with you later. I think I saw one similar to it here. Let me look. Nope. I think. Sure. Something like this. I'm going to give you kind of a question that's combined. It'll be written not multiple choice, but that's okay. And what I mean by this is going to be the last question on the test, so you know when it's coming. Okay? I'm going to give you both groups and arrangements. This is a combined Scrabble tile with letters on there. This is very similar to that math, English, physics one that we did a little while ago as well. So the number of different arrangements, hey, that's shuffling, permutation, of 3 boys and 4 girls in a row, if the girls must stand together, is represented by So I'm going to visualize my Scrabble bag like this. How many boys in the Scrabble bag? Can I call it B1, B2, B3? How many girls in the Scrabble bag? But what's the condition? So I'll put in one big Scrabble tile with girl 1, girl 2, girl 3, and girl 4. Yeah? Okay. First thing is, how many tiles do we have in that bag? Don't say 7. How many different tiles are there? 1, 2, 3, 4. I mean, this is a weird time, but 4 tiles. So how many ways can I mix those up? Okay, so there's definitely going to be that. That's the number of ways I can just mix up the stuff in the bag. But I can mix that up as well. How many ways can I mix up that tile? You were wanting to pick D. You were looking at, I think we've shuffled everything, though, in my method here. I think we've taken care of the fact that we can mix the boys up as well. We did, because we treated them as separate Scrabble tiles. All we said is, if the girls got to be in a clump, okay, then we'll treat them as one huge Scrabble tile, and then afterwards we'll figure out how many different ways we can mix up that Scrabble tile. So we did the restriction. The restriction was the girls must be together. We took care of that first. That's where the 4 factorial came from. And then we said, let's remember that the girls could mix up. Okay? What if this had been 5 girls? It would still be 4 factorial tiles, and then 5 factorial ways you can mix them up. Okay? Folks, that's pretty much the whole test. Any specific questions you want me to go over, I'm willing to stick around, or if you want to, we can call her a day. It's up to you. Remember, I have 2 other tutorials online. And again, when you watch the other ones, if you do, just ignore the constant term, find a constant term ones, although they're kind of nerdily cool.
Everything we went over today is what we're looking at for the test.
I've covered 90% of the test. I think there's a multiple choice question that I haven't talked about today, but I've done a huge song and dance about it because it showed up on almost every quiz. And I think said when I taught you it, I like this question, so I didn't do a big song and dance today about that. Okay? I will say this. If you work your way through that big, huge unit review, which I think most of you still haven't finished, and that's fine. If you finish that by Wednesday, there will not be a single surprise on the test. Then it's just going to be, don't make mistakes.
How much is the test out of?
40, 35. Sorry, actually same as your finance test. Turns out. Yep. Any other questions at all? Do you have a question?
Just number 9.
From the big review?
Yes.
Sure thing. Did you look at my online answer key showing all my steps?
Oh, not yet.
Then,
Oh, I guess we could actually.
hang on.